Hello, welcome back once again. Today we have another interesting definite integral, right? We have the integral from 0 to 4 of x minus 1 plus x minus 2 plus x minus 3. You can see this sum continues up to x minus 100. So it is a finite sum, right? So in this video, I'll be presenting two different methods. So let's begin with the first method. So let's start with the first method and see how it works, okay? So for my first method, we're going to express this integral as the integral from 0 to 4. So remember we have x plus x, right? Plus x plus x. You can see it. This is x. It is positive. This is x. It is positive. This is x. It is positive. This continues up to hundreds of x, right? So this sum continues plus x, but we need to denote this that this is 100 times, right? Yes, of course. So this is 100 times. And again, we have negative values. Negative 1, you can see it here. We have negative 2. We have negative 3 up to negative 100. So this one we can write it as plus, then we have negative 1 plus negative 2. So this sum continues up to negative 100 and we have our dx. Okay, so now we have I is equal to the integral from 0 to 4. So since we have this sum of x up to 100 times, so it is the same as 100x, right? And then remember, plus times minus here is minus, so we have minus 1. Plus times minus here is minus, so we're going to have minus 1, minus 2, minus 3, minus 4, minus this continues up to minus 100, and then we have our dx. Next, our I is equal to integral from 0 to 4. So we have here 100x, and we can take away the minus sign, and we're going to have positive 1 plus positive 2 plus positive 3 plus positive 4 plus positive 5 plus this continues up to 100, and then we have our dx. Now let's take note of the following. We know this nice formula for the sum of the first n natural numbers, right? So we know that 1 plus 2 plus 3 plus 4 plus 5 plus this continues up to the nth term. So this is equal to n into bracket n plus 1 divided by 2, right? Now take a look at the one in the bracket. So we're going to let our n equals 100, so that this will give us the sum 1 plus 2 plus 3 plus 4 plus 5 plus up to 100, that this is going to be equal to 100 into bracket 100 plus 1, which is 101, then divided by 2, and this is going to give us 50. Because 100 divided by 2 is 50, then 50 times 101 will give us 50, right? So therefore our I is going to be equal to the integral from 0 to 4. Remember we have 100x, then minus, so that sum there is 50, and then we have our dx also, right? So let's check it out. Yes, 100x minus 1 into bracket, so the bracket there, the sum is 50, then negative 1 times 50, that will give us negative 50. So I think from here this is very cool from here, because this is going to be equal to 100 multiplied by the integral from 0 to 4 of x dx, then minus, we're going to have 50, the integral from 0 to 4 of 1 dx, right? So from here I is equal to, so this is going to be 100, then the integral of x is x squared divided by 2. Remember our limit from 0 to 4, and then minus, here we're going to have 50 into bracket, the integral of 1 dx is just x, and we have our limit from 0 to 4. Now no need for the lower limit, right? Because putting in the lower limit turns everything to 0. So we're just going to insert the upper limits. So our I is going to be equal to 100 times. So if you put in 4 here for x, we'll get 4 squared divided by 2. That will give us 8. And then minus here, we're going to have 50 times 4, right? 5050 times 4. So our I is going to give us 800 minus. So this is going to be 800 minus 2200, right? So 2200. And this is going to give us the required answer, which is negative 19400. Hope I'm correct. Yes, of course. So our right answer to this problem is negative 19,400. Oh my god, this is awesome. So this is the answer. Then let's go to the second method and see how the second method. So you guys should choose from the first and the second method which method is better. Okay, so remember our I is equal to the integral from 0 to 4. So we have the sum x minus 1 plus x minus 2 plus x minus 4. This continues up to x minus 100, and then we have our dx. So we're going to express the sum in summation form, right? So this is going to be integral from 0 to 4. Then this is same as sum as n goes from 0. Is that 0? No, it's going from 1. Oh, that's true. So sorry for that. So our n is going to go from 1 up to 100. I'm 100% sure of that. Then x minus n. Then dx. Wow. So you can see if n is equal to 1, we get x minus 1. And here it is. We now have plus. If n is equal to 2, we get x minus 2. And here it is. So this continues. So now we're going to switch the integral sign and the summation sign. So this is going to be sum as n goes from 1 to 100. Then we have the integral from 0 to 4. Then we're going to integrate x minus n with respect to x. So this is going to give us sum as n goes from 1 to 100. And here the integral of x is x squared divided by 2, right? Then minus the integral of n with respect to x will give us nx. And then we have our limit from 0 to 4. So remember again, we're not going to, well, it is very compulsory to put the, or should I say, it's very convenient to make sure that you take the upper limit and the lower limits, right? But if you put in 0 for x here, everything turns out to be 0, right? So therefore, we're going to make use of the upper limit. So we have sum as n goes from 1 to 100. So if you put the upper limit, we get 4 squared divided by 2. That will give us 8. Then minus. So if you put the upper limit for nx, we get 4n, right? Then you can see if you put the lower limit, we're going to have 0 minus 0. So you can see that's why I said no need for the lower limits, right? Because it will turn everything to 0. So this is sum as n goes from 1 to 100. Then we have 8 minus 4n, which we can write as sum as n goes from 1 to 100 of 8. Then minus sum as n goes from 1 to 100 of 4n. Okay, so let's take note of the following. We know that the sum as n goes from 1 to k of n. So this is equal to n times k. Don't forget this. This is really very compulsory. So here we have sum as n goes from 1 to, let's say we have, are you sure? No, I don't think so. Oh my god, that's a very silly mistake. So this is a very silly mistake. So this is n into bracket, oh sorry, I mean k, not n. Oh my god, I don't know what is wrong with me today. So this is going to be the k multiplied by k plus 1, then divided by 2, yes, of course. Then when we have sum as n goes from 1 to k, right? And let's say we have a constant a. Therefore, this one is the one that will be equal to 8 times k. So therefore, this part is going to be 8 times 100. Then minus, so this part we have 4, so we're going to multiply. Remember, here, this one, if you take out the 4, which you have right over here, then the sum as n goes from 1 to 100 of n, which is similar to this, is going to be 100 times 100 plus 1, which is 101, and then divided by 2. Okay, yes. So from here, our I is going to be equal to 800 minus, so that will be 4 into brackets 50, 50, which we have had earlier in the first method, which we know that this will evaluate to negative 19,400, and this is the correct answer. Thank you for watching. Please, if you really enjoyed this video, please kindly subscribe to the channel. Also like, comment, and share.